So here we have these set up for the reflection and refraction lab that we're going to be performing today. So the difference between reflection and refraction is reflection, as we have shown here, is light bouncing off of a surface, whereas refraction would be light passing through a surface, but its path being altered as it passes through, so it would go out as a different angle than where it entered. So as we can see here, we have our light source and a simple reflective surface, i.e. a mirror. And so what we're going to do here is we're going to take note of the plane where the mirror was, and we're going to very carefully draw that out. And we're going to take note of the exact spot where it bounces off the mirror to begin with. But first we're going to trace the path itself as well. The important thing here is to make sure you're tracing out the path exactly, as this is a very close angle measurement we're relying on here. So once you have your path plotted out, what you're then going to do is circle everything to make sure you're getting the path correct. And draw your straight lines. Just makes measuring the angles much easier than before. After this, you want to make sure you have the normal to your surface pointed out. And the normal is just a 90-degree angle to your surface of reflection. And so per the law of reflection, the two angles that we've now segmented with this normal line should be the same. And that's what we're going to hope to obtain here. We're going to measure both of those angles segmented by our normal line and hope that they are, in fact, the same thing. And it looks like we're getting pretty close. So that's part one, and this demonstrates reflection rather well. So now what we're going to do is we're going to highlight refraction, which is similar but a little bit different. So instead of a mirror with a blacked out backside, we now have a full crystal, which is reflecting some of the light but refracting other parts of it. So like before, we're going to trace out the line of our shape, and we're going to note the path that the light is taking. It's a little harder to see, but there is a slight reflection coming off here, which we are dotting now. So same as before there, if we segment that with the normal, it should give us the same angle coming in as it is coming out with respect to that normal line. But on the other side, you can see that there is light passing through this crystal. But as we're going to try to show after, the angle is going to be slightly different than before. So now what we're going to do is we're going to do the same thing as before, and we're going to take a second to trace out all the lines that the light was following. And again, make our normal, but this time we want the normal to extend into the medium as well. In this case, we're using simple glass, which should have a refractive index of about 1.05, which is slightly more than that of air. And so now what you're going to see is, with the line of the light that went through the glass compared to our normal line, it also has an angle. But the angle of refraction should be, in this case, smaller than the original angle that the light came in at with respect to the normal. And you'd go through the same process as before, this time trying to verify that the refracted angle is in fact less. And then you would use the law of refraction to then try to back calculate what the index of refraction for this material is and verify its identity. And that's all there is.